Welcome to section 4.1, where I'll give you some other example problems that you may be seeing on your exam that will help better clarify some topics. What is a random variable? Give an example of a discrete random variable and a continuous random variable. Justify your answer. Well, let's start out by talking about what a random variable is. It's very tempting when we hear the word random. Think of this as a random event, but it's not. A random variable represents a numerical value associated with each outcome of a probability experiment. When dealing with a continuous random variable versus a discrete random variable, a discrete random variable means that it's countable, it's not continuous. So for example, if I were to say the number of students in a class, that would be a discrete random variable. If I were going to talk about the ages of people, that would be a continuous random variable. And the reason why age is a continuous random variable is when we talk about someone's age, we very often give it as an even number, like a person's 20 years old. That's not really accurate, because a person is not just measured in years. They're measured in days, hours, minutes, seconds, and by the time you're done mentioning someone's age, it's changed. And regardless of how far down in a measurement you go down to a tenth of a second, a hundredth of a second, a thousandth of a second. It continues infinitesimally small. So there is no such thing as a termination to the value. It's continuous. Other examples of continuous measurements would be someone's weight, someone's height, the length of a car. Items like that, usually measured values, are best described as continuous. Anything you can count would be a discrete random variable. Let's take a look at examples and talk about how we can tell whether they're discrete or continuous. Obviously, number 9, we're noticing that these are discrete variables because notice that each one of these are independent of one another. They're not continuous. There's a break between them. They're actual single values. Notice as we go over to number 10, there's infinitely many numbers that exist on this number line. This line is continuous. There's no break in the line. Likewise, you can see the same thing in number 11. And in number 12, you notice that they're actual units. Let's look at what's being described in each. Here we have the attendance at concerts for a rock group. This is the same as I mentioned before with the number of students in a classroom. The length of time student athletes practice each week. This is the same thing as if we're talking about a person's age. Age is continuous. Any measurement of time is. The distance a baseball travels after being hit is length. Again, it's a measurement, hence why it's continuous. The annual traffic fatalities in the United States, we notice here again, it's a discrete number. It's not a number where there's going to be a partial number where they're going to be all the numbers touching. Using interpreting concepts. Let X represent the number of books in a university library. Well, this would be a discrete value because you can actually count the number of books in the library. Let X represent the length of time it takes to get to work. Again, this is a measurement of time. It's measuring something. It's continuous. 15. Let X represent the volume of blood drawn from a blood test. Again, this is a measured value, hence why it's continuous. Let X represent the number of tornadoes in the month of June in Oklahoma. Because it's counting something, this is a discrete value. Let X represent the number of messages posted each month on social networking website. Again, it's counting something. So again, this would be a measurement that would be defined as discrete.